Okay, so now we move on to the next part of our lesson, vector planes. Okay, so they say here we can write the, so we are going to learn how to write the equation of the plane in what we call the first form that we are going to introduce you is the scalar form. Okay, so you are going to learn how to write the vector planes in the scalar form, how to write the vector planes in a vector form, and also in a Cartesian form. So you are going to learn 3 ways to express a vector plane. Okay, so first of all, how does a vector plane look like? So vector plane is basically like a 2D plane, right? So like a paper, a 2D plane, a vector plane is a 2D plane. So basically it's spreading out, right? It spreads out. Then, so now the first thing we are going to do is we will learn how to find the scalar form of the vector plane. So given that the vector n is perpendicular to the plane phi and that phi passes through the point A with question vector A, find an equation of the plane phi. Okay, so they're just giving here the naming the plane like we use capital letters. Okay. Like in a parabola, hyperbola, we use capital letters C, P we use, right? Similarly, we use this notation. This notation is used to denote a plane. Okay, so they say here, given that the vector n is perpendicular to the plane phi. So how do I draw it? The vector n is perpendicular to the plane phi. Okay, and the plane passes through the point A. So your plane is passing through some point A here. So your plane is passing through some point A, means this point A is what? Point A is a position vector on your plane. Point A is a position vector on your plane, and n is what? N is a vector who is perpendicular to the plane. Do you agree with me? So very clearly again, let's say OA. Who is OA? Let me say OA is vector A. That means it's the vector when you measure the position vector. When you take with respect to the origin, the position vector of A is simple A. Okay, and then another person that I introduce here is I'm going to take a point called R. Who is R? R is going to be what? Who is R going to be? R is going to be any point who what? Lies on the vector plane. R is going to be any point who lies on this plane. It can be anywhere. As long as what? As long as it lies on this plane. Okay, A is a very specific point. Now A does not have any movement because A is a fixed point on the plane. But R is a general point, which means it can go anywhere as long as it stays on the plane. Okay, so let's say my OR coordinate is R, simple R. Okay, so what do we do here? Now you can see here, when you take the vector plane, regardless of where your R is, now let's say these are different positions that I'm marking for R. Okay, I'm marking different positions for R. Do you notice something about the AR vector and the N vector? If I take the AR vector like this and the N vector, regardless of which direction you take AR vector, you can see AR is always going to be on this horizontal plane, right? I mean, R can be anywhere on the plane. Now, AR is always on this flat plane, while N is vertical to that horizontal plane, which means what? Regardless of where R is, AR vector will always be what? Perpendicular to vector N. Do you agree? AR vector will always be perpendicular to N. Okay, so then we learned a special rule about perpendicular vectors not in this one. In here we learned about the cross product. So we learned that parallel vectors become equal to the cross product of parallel vectors become 0. But when it comes to perpendicular vector, you learned in P4 that the dot product of what vectors? Dot product of perpendicular vectors become equal to 0. Now, this is theory you learn in P4. So basically, what are our two perpendicular vectors here? AR. So AR is definitely what? Perpendicular to N, right? AR is perpendicular to vector N. Therefore, I can write AR dot N is equal to 0 because the dot product of two perpendicular vectors becomes 0. Do you agree with me? How do I write the vector AR in the position vector form? It's R minus A, right? So I get here R minus A dot N equals 0. So R minus A dot N gives me R dot N minus A dot N equals 0. Okay, I expanded the bracket with the dot N. So r dot n minus a dot n equals 0. So I take the minus a dot n to the other side as plus a dot n. Okay, so then I get this equation r dot n equal a dot n. Now you know r is an unknown, right? R is x, y, z, so it can be any unknown coordinate on your plane. But n is it something unknown? No, n is a vector perpendicular to the plane and it's given to you. And what about a? Is it an unknown or is it a known vector? It's a Persian vector and you definitely know it. So what happens when it comes to the person a dot n? Do you see that I can actually get the real figure of a dot n, and a dot n will actually be a single digit, a single figure, not a single digit. It will be a value. You get some kind of integer or rational value. Okay. So basically we could say it's r dot n equals to p because you get a constant. P is a scalar constant. You get a scalar value here. Okay. So then this is the scalar form of a vector plane. This is the first equation you need to know. Basically, this is what you mainly know. R dot n equals to a dot n, where a is a position vector on the plane and where n is a vector who is perpendicular to the plane. Okay. Okay, so now we move on to the next part, Cartesian form of the vector plane. So how do we get the Cartesian form of the vector plane? So basically, when you take this vector plane, a Cartesian form is where you give the vector plane in terms of what? X, Y, and Z. That's what we mean by Cartesian. How do we make it into Cartesian? Now I already got the scalar form, right? R dot n equal a dot n or r dot n equal p. So then what we'll do here is, let's take the n vector. Now n is the perpendicular vector to the plane, right? So let's take n coefficients as n1, n2, n3. For r, we will use r is going to be a general point on your plane, right? R is going to be a general point on the plane. Therefore, for r, the coordinate should be x, y, z. Okay, so n is a vector who is perpendicular to the plane. Basically, you have ijk coefficients. So I used n1, n2, n3 for the ijk coefficients of the perpendicular vector. R is a general coordinate on your plane. So shall we use the help of our equation? R dot n equal p. So R is x, y, z. Dot n is n1, n2, n3 equals to p. Now you know p is a constant. Okay, so p is a constant. Let it be there. Let's get the dot product. So x into n1 is xn1 plus yn2 plus zn3 equals to p. Do you agree with me? So I multiply, I take the I take the I coefficient and multiply with I. So you keep on adding like that, the j coefficients and the k coefficients, and you equate it to p. So do you see that here n1 is actually a coefficient, right? So I get a coefficient of x plus a coefficient of y plus a coefficient of z equals to another constant. So do you see I actually have an equation with x, y, z in terms of constants. So this is the Cartesian equation of your vector plane. Okay. Okay, so now we go on to the vector equation of a plane. So we learned two formats now, the scalar form of the plane, the Cartesian form of the plane, and now we are going to learn about the vector equation of a plane. Okay, so once again, we have a few things that we need to know here. The first one is, again, we say our plane is passing through a point A. So point A is basically a position vector on the plane. Okay, and then we take, they say here, so then let R be a general point on your plane. So basically, it's the same thing I took previously as well. R is going to be any point as long as it's on the plane. Okay, so then let's go to the so to describe the vector equation of a plane, we actually use the help of two direction vectors who lie on the plane. Now, do you see in this particular question, they are, you don't need to have any definitions of this, but all you need to know is to get the vector equation of a plane. Basically, what you need is you need two direction vectors who lie on this plane. So do you see the equation? The vector equation of a plane is r equal a plus lambda b plus mu c, where a is the position vector of a point in the plane. Obviously, A is a point, a position vector of a point who is lying on the plane. B and C are non-parallel vectors. So B and C shouldn't be parallel. Now, when it comes to a plane, you can get many direction vectors going on the plane, right? So B, I could take B going like this, and C could be something that goes somewhere else. But it's all B and C, all of these direction vectors are lying on the plane. It's on this horizontal plane. Okay, so then when you have, if you know two direction vectors on your plane, you can write the vector equation. R equal A stands for a position vector, plus lambda b. So lambda is the parameter, right? Lambda b plus mu c. Mu is another parameter. So you need to have two parameters. Now, when you were defining a vector equation of a line, do you remember in P4 we used only how many parameters? Only one, R equal A plus lambda b. But when it comes to a plane, we have two parameters. And we have how many direction vectors? We have two direction vectors. So this is the important thing. Okay, so you need to remember this. To get the vector equation of a plane, we need a one coordinate who is fixed on the plane, and we need two direction vectors on our plane. Okay. Exercise 5e, question number 1. Find in the form r dot n equal p an equation of the plane that passes through the point with position vector A and is perpendicular to the vector n, where A equal. So they've given you A and n, right? What do we do here to get the vector, to get the scalar form of the equation? So equation input r dot n equal p. How do we get p? You know, p is equal to a dot n. So let's input the value of r dot n is 211 equals a is 1 minus 1 dot n is 211. So you can get the dot product here, right? R dot 211 equal, when you take the dot product, 2 into 1 is 2, minus 1 into 1 is minus 1, plus minus 1 into minus 1 is minus 1. So basically r dot, I'll write here 2y plus j plus k equals 0. So that's it. Okay, so it's quite simple. And then in the next question, is find a Cartesian equation of the planes in question 1. How do I make it Cartesian? How do I make this Cartesian? Instead of r, now you know r is a general point. For r, we could substitute xyz dot product with 211 equals to 0 here. So I get 2x plus 1y plus 1z, you multiply, equals to 0, and thereby I get the Cartesian equation of the plane. Is that clear? Shall we do question number 3, part A? Find in the form r equal a plus lambda b plus mu c an equation of the plane that passes through the points. Okay, they've given you 3 points on the plane. How do I get the equation of the plane that passes through all the 3 points? So basically, you have your plane. They've given you, let's say there are 3 points. A is 1, 2, 0. B is 3, 1, minus 1. C is 4, 3, 2. So how do we get the vector equation of a plane? You know, the vector equation of a plane is r equal a plus lambda b plus mu c. A is going to be what? A position. Okay, so moving on to question 3, find in the form r equal a plus lambda b plus mu c an equation of the plane that passes through the points 1, 2, 0, 3, 1, minus 1, 4, 3, 2. So these are 3 points that lies on the plane. So you need to find the vector equation. Now you need to find the equation of the plane in this particular form, right? So how do we get it in this form? You know, A is a position vector on the plane. How many position vectors do I have on the plane? There are 3. So for A, I could use any one of these 3. I could use any one of the 3. But what about B and C? I told you very specifically B and C are supposed to be what? Direction vectors on the plane. They are definitely direction vectors on the plane. So what are the direction vectors that I can use here? So let's say for vector A, simple A, I'll use the OA vector. Is that okay? Now you could use OB, you could use OC. It's entirely up to you. So I'll use OA. So what about B? For vector B, shall we use AC or AB? Anything. And for C, I'll use AC. Or you could use BC because I took point A. I'm going to take it around point A. Okay, is this clear? Okay, so now what you need to do is, I mean, B and C, you could take anything. I mean, you could take BA, you could take BC, you could take CA. It's just Any two vectors as, who are on this line. You could take any combination. Is that clear? Okay, then what we do here is let's get the equation. Can you all find AB and AC? So vector B is B minus A, which is 3, 1, minus 1. Subtracting with A is 1, 2, 0. So I get here 3 minus 1 is 2. 1 minus 2 is minus 1. Minus 1 minus 0 is minus 1. C vector AC, we get C minus A, which is what? 4, 3, 2 minus A is 1, 2, 0. So I get C is 4 minus 1 is 3. 3 minus 2 is 1. 2 minus 0 is 2. Right? So then I got my B and C. Now all I need to do is to input to the equation. R equal. Yeah. So R equal A plus lambda B plus mu C. Or you could write here R equal OA plus lambda times the AB vector plus mu times the AC vector, so that you know exactly what you are working with. So OA is 1, 2, 0. Lambda times the AB vector was 2 minus 1 minus 1. Mu times the AC vector was 3, 1, 2. Okay, so this is a possible, this is the vector equation of your plane. So now I'm moving on to part B. We'll do another one question with this particular section where we need to find the vector equation of a plane in this particular format. There again, the three coordinates are 3, 4, 1, minus 1, minus 2, 0, and 2, 1, 4. So again, I've done the basic parts here. We have our three coordinates. So we find the position vector. The first one, I'll take OA as the position vector on the plane. AB and AC are the two direction vectors that I'm going to consider. Okay, so this is already found similar to the thing that we did in the previous part. And then we do R equal A plus lambda B plus mu C. So what do we get here? A is 3, 4, 1 plus lambda times B is minus 4 minus 6 minus 1 plus mu times C is minus 1 minus 3, 3. Okay, so this is the vector equation of the plane. Is this clear? Okay, so now we'll move on to the next part. Okay, in the next part, they ask you in question number 4, find a Cartesian equation for each of the planes in question 3. Which means what? Now in question 3, part A, so I've done question 3, part A here. This is question 3, part A. And question 3, part B, I've done two parts here. They're asking you to find the Cartesian equation, which means what? Cartesian equation means the XYZ form, right? So how do we find the Cartesian equation? From the vector form, how do I convert the vector form to Cartesian form? I think you might remember we have this scalar form that we used previously. Okay, so in the fourth question, do you remember if I have r dot n equal a dot n, it's quite easy for me to find the Cartesian equation, right? Why? For r, I could simply use xyz. And the thing is, to find the Cartesian equation of the plane, you must first convert this vector equation into this format. Do you see this format? What is this format? In this particular format, you have r dot n equal a dot n. Who is n? N is a vector who is perpendicular to the plane. N is a vector who is perpendicular to the plane, and A is a vector who? A is a position vector of a point on the plane. So how do I find? Now the biggest question here is, using all this information, how do we find n? How do we find a vector who is perpendicular to the plane? So to do that, you just need to remind yourself about the basic, the main part that we learned in this lesson. In the very first exercise, we learned something about perpendicular vectors. What was it? The cross product. If you take the cross product of any two vectors, the cross product of any two vectors produces what? A vector who is perpendicular to the two original vectors. That's the definition of cross product, right? The definition of cross product was A cross B was, if you have A and B, if you take the cross product of, if you take A cross B is perpendicular to A and also it's perpendicular to B. So that's the purpose of cross product. So in this case, using that theory, how can I get a vector who is perpendicular to this plane? How can I find n? What's the theory behind finding n? You can see we have two direction vectors here, right? We found AB and AC. Right? So then what do we do here? Since both of them are direction vectors on the plane, what I could do is I could take the cross product of AB and AC. This gives me what? This gives me a vector who is perpendicular to the plane. It's perpendicular to both AB and AC, which means automatically it will be perpendicular to the entire plane because it's perpendicular to both of them. This is clear? So what you need to do right now is you need to find n. So you can write here n equals to the cross product of the B and C. So B cross C, basically here the B and C, the two direction vectors, we need to take the cross product of the two direction vectors and that gives you n. Is that clear? So basically AB cross AC. Let's get the cross product. AB we know. AB we found it as what? This was AB, right? This B is AB, which is 2 minus 1 minus 1. Cross product with AC, our AC vector was C, which is 3, 1, 2. To take the cross product, we take the a 3 by 3 matrix. 2 minus 1, 1 minus 1, 3, 1, 2. Plus minus plus. So n equals I times minus 1 into 2 is minus 2 minus 1 into minus 1 is minus 1. Minus j times 2 into 2 is 4. Minus 3 into minus 1 is minus 3. Plus k times 2 into 1 is 2. Minus 3 into minus 1 is minus 3. So I end up getting n equal minus 2 plus 1 is minus 1i. 4 minus minus is 7. Minus 7j plus 5k. So this is my n vector. So now shall we transform it into the Cartesian format? So what do we get here? R dot n. N is minus 1, minus 7, 5. R dot n equals to what? A dot n. Who is A dot n? A is the position vector on the plane. Who is A? I will be using OA, which is 1, 2, 0. The position vector of A is 1, 2, 0. R dot n equal A dot n is minus 1, minus 7, 5. So R, I'll be using instead of R what? R should be XYZ, right? So this is basically R dot n equals A dot n. Then I get here minus x minus 7y plus 5z equals 1 into minus 1 is minus 1 plus 2 into minus 7 is minus 14 plus 0 into 5 is 0. Minus x minus 7y plus 5z equals to minus 15. Okay, so this is the, you could change the negatives to positives here and get, and they make the equation maybe equal to 0. Yeah, so this could be your answer. Okay, so moving on to question number 6. Find in the form r dot n equal p an equation of the plane which contains the line L and the point with position vector A. So they have given you, they are saying there's a plane and they have given you a line on the plane. Can you see the line on the plane? R equals 1, 1 minus 2 plus lambda times 2, 0 minus 1. Okay, so this is the R equation. And I mean, this is the, I mean, basically you have this line which goes on your plane. Okay, do you see? This line L goes on the plane and there is this point A, which is how much? 4, 3, 1. Okay, so this is the point A, which is the position vector on your plane. Now they are asking you to get the equation of the, they are asking you to get the equation of the plane in terms of r dot n equal p, which means r dot n equal a dot n. So what's the biggest thing you need to find here? First thing you have to do is you have to find n, a vector who is perpendicular to the plane, right? How do we find a vector who is perpendicular to the plane? Cross product of what? If you want to find a vector who is perpendicular to the plane, you have to get the cross product of two direction vectors on the plane. Can you take cross product of like position vectors? No. So your task here is to create two position vectors. Okay, so now they have given you a line and they have given you a single coordinate. How do you get two direction vectors? Think about it, because the cross product of the two direction vectors will give you the end. Question is, how do you find those two direction vectors by using this given information? Okay, so now the task is how to get the two direction vectors on the plane, because we need two direction vectors to take the cross product and find n. So the first thing here is we notice that this is r equal a plus lambda b. So our b is the direction vector of the line. Since the line is lying on the plane, the direction vector of the line also becomes what? It also becomes the direction vector of the plane. So this b20 minus 1 is actually a direction vector of your plane. I mean, the direction of the line also, because it lies on the plane, it becomes the direction of the plane as well. So I need another one direction vector. So how do I get that other one? They have given me a position vector here on the plane 4, 3, 1. So you can see here, when you take the equation of the line r equal 1, 1 minus 2, this particular coordinate, this particular person here is supposed to be a position vector that lies on the line. So if it's lying on, if it lies on the line, we know the line is also lying on the plane, which means, in other words, the point 1, 1 minus 2 is a position vector on the line. Also, it will be a point on the plane. So now I have two position vectors that lies on my plane. So I can get my second direction vector by considering the PA vector. I just named this coordinate as P. You could give it any letter you want. I just randomly gave it the letter P. Okay, so basically I just need to find the PA vector. PA would give me the second direction vector on top of my plane. So let me get PA. How do we find PA? PA is A minus P, which is 4, 3, 1 minus P is 1, 1 minus 2. What do we get? 4 minus 1 is 3, 3 minus 1 is 2, 1 minus 2 is 3. So this is the PA vector. So this is the second direction vector on the plane. So now what do we do to find n? I have the two direction vectors, right? So you could write, first you could use this information and actually write the vector equation of the plane. What's the vector equation? R equal a plus lambda b plus mu c, right? Where a represents a position vector on the plane. I'll use 4, 3, 1. You could even use 1, 1 minus 2 plus lambda times b will be the direction vector, the first direction vector of our plane, which is 2, 0 minus 1 plus mu times the second direction vector of our plane is PA, which I found as 3, 2, 3. So now we'll find our n. N equals to the cross product of 2, 0 minus 1 with 3, 2, 3. So get the cross product. The cross product is the determinant of a 3 by 3 matrix. 2, 0 minus 1, 3, 2, 3. So plus minus plus. N equal I times 0 minus 2 times minus 1 is minus 2. Minus j times 2 times 3 is 6. Minus 3 into minus 1 is minus 3. Plus k times, remove the row and column, 2 times 2 is 4, minus 3 times 0 is 0. So I get here n equals plus 2i, 6 minus minus is minus 9j plus 4k. So this is my n. Now they want us to find the equation of the plane in the form, which form? R dot n equal P, which means what? I need to get R dot n equal A dot n. So R dot n, R is x, y, z, dot n is 2 minus 9, 4 equals A is, who is my A? 1, 1, 4, 3, 1. We could even use 1, 1 minus 2. Both are okay. 4, 3, 1 into n is 2 minus 9, 4. 4, 3, 1, right? N was A value. A was 431. Yeah. N was 2 minus 9, 4. Okay. So multiply x into 2 is 2x, y into minus 9 is minus 9y, z into 4 is 4z. 4 times 2 is 8, 3 times 9 is minus 27, 4 times 1 is 4. 2x minus 9y plus 4z equals minus 15. Taking everything to one side, 2x minus 9y plus 4z plus 15 equals to 0. So this is the Cartesian equation of the, actually they asked us to find the equation in the form r dot n equal p, right? We didn't find that. So actually we don't need to find all of this. We just need to keep we only need to get the p value, which is minus 15. So basically you need to keep your answer in the format r dot n is 2 minus 9, 4, r dot n equal p value is minus 15. This is all you need to keep. This is the way they ask you to give the answer. So give it in that form. The question was to keep it in the form r dot n equal p. Okay. Question number 7. It's again quite similar to question number 6. Find a Cartesian equation of the plane which passes through the point 1, 1, 1. So the plane passes through the point. Let's say the point A is 1, 1, 1. And passes which passes the point 1, 1, 1 and contains the line L with equation. So what's the line equation? So when they give you in this form, you can convert it to r equal a plus lambda b, right? Because on top you get the question vector. So we just learn how to convert Cartesian to parametric, right? On top you get the question, at the below you get the direction. So x minus 2 means question vector is 2, y plus 4 means it's going to be y minus minus 4. Okay, we discussed about this in the previous part. Z minus 1 means the z coordinate is 1. Lambda times the direction vectors are 3, 1, 2. Is this clear? Which means a direction vector of the line would be 3, 1, 2. So 3, 1, 2 is the direction vector of the line. And what is the other thing? 2 minus 4, 1 is a position vector on your line. 2 minus 4, 1 is a position vector on the line, because the line is lying on the plane, 2 minus 4, 1 is becoming a position vector on the plane as well. Okay, so I'll take this point as point P. Use any letter you like. So end of the day, I need two direction vectors. So I'll get the PA direction vector. PA is A minus P, which is 1, 1, 1 minus P is 2 minus 4, 1. 1 minus 2 is minus 1. 1 minus minus is 1 plus 4, 5. 1 minus 1 is 0. Is this okay? Then we'll get the cross product of PA. So PA vector is, if I write the equation R equal A plus lambda B plus mu C. A is the vector, I'll use 1, 1, 1. You could use any of the two direction vectors for A. Okay, and then lambda B, I'll use 3, 1, 2 plus mu. For C, I'll use minus 1, 5, 0. Okay, so for n, I gave you the rule n is equal to b cross c. So 3, 1, 2, you take the cross product with minus 1, 5, 0. So n equals ijk. So it's 3, 1, 2 minus 1, 5, 0. So we use plus minus plus. We get n equal I times 1 into 0 is 0, minus 5 into 2 is 10, minus j times, removing the row and column, 3 times 0 is 0, minus minus 2, plus k times 3 times 5, 15, minus 1 into 1 is minus 1. Minus 10, 9, plus 2j, 15 minus minus is 16. Minus 2j, yeah, it should be minus 2j. Plus 16k. Do you agree with the n value? Okay, then we are supposed to get the equation in which form? Find a Cartesian equation. That means we need to get the full value. R dot n equal A dot n. So for R, we use XYZ dot product of n is minus 10 minus 2, 16 equal A dot n. Who is A? A was 1, 1, 1. So we could use either 1, 1, 1 or 2 minus 4, 1. Yeah, it's easier to multiply. N is minus 10 minus 2, 16. Basically, you could use anything. Answer will be the same. Even if you use the other coordinate, the two position vectors, any of them would be okay. So minus 10x minus 2y plus 16z minus 10 minus 2 plus 16 minus 10x minus 12 plus 16 is 4. So I think everyone is divisible by 2. And I'll take everyone to the other side. Dividing by 2 and taking to the other side. Minus 10. When you divide by 2, it's minus 5. I take here, it's 5. Minus 2 divided by 2 is 1. I'll take it here, plus 1y. 16 divided by 2 is 8. Taking to the other side, minus 8z. 4 is already over here. So I don't need to change signs. 4 divided by 2 is 2. So this is the Cartesian equation of the plane.